we are going to be doing proofs, like real proofs, all by yourself proofs, okay? They are simple proofs because I'm going to teach you how to know what the progression is immediately. So you're not going to find them that bad, but you've got to identify how you're going to do your proof, in what order. Because if I told you to do your proof in this order, wouldn't it be a lot easier for you to do? If you knew what order to do it in? Yeah, it would be. So this right here, I've given you this sheet. Eliminate the possibilities when finding congruent triangles. You're going to use one of these to progress your proof. So I would title this 4-4, Proving Triangles Congruent. Pardon? Yes. Uh-huh. Well, not all of them. All right, so it's hole punch because it needs to go either in your math binder or you need to cut this part off and paste it into your note spiral. It's a very important sheet for you. All right, so the very first one we've already had before. Definition of congruent triangles. So, and does it apply? This is really what we're going to use to see what we're going to do for the proof on the back, which we're going to do shortly. But for right now, you can just write some notes in there. Basically, you're going to look at the proof that I give you, like this one here, and you're going to look at the information you've been given. You're going to look at the picture and see, well, what else can I prove? And you're going to decide which one of these applies to that particular proof that we're going to do. And that'll help you decide what to do on that proof. So prior to this, in the first 3 sections of chapter 4, didn't we learn the definition of congruent triangles? Didn't we learn that there are 6 parts to triangles? And if you could prove that all 3 sides and all 3 angles were congruent, then the triangles also had to be congruent? True? True. What was that shortened form called? CP, CTC. That might still apply in some of your proofs. But we're going to shorten that up. I don't want to have to sit there and prove 6 different things in my proof because it's going to end up being anywhere from a 6 to a 10-step proof. And we're going to go to a 4 to 5-step proof, which is a lot easier. If I gave you the following, the first one is SSS. It is postulate 4-1. It's commonly referred to as side, 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 which is why it's SSS. And it essentially says the 3 sides of one triangle must be congruent to the 3 sides of the other triangle. If I gave all of you 3 toothpicks of different lengths, let's say I gave you 1 toothpick that was that length, 1 toothpick that was that length, and 1 toothpick that was that length. And I gave each of you all exactly the same toothpicks. Wouldn't you all build exactly the same looking triangle? Is there any way to build a different triangle?
No, those are imaginary.
Well, you can't break the toothpicks or lengthen them. But isn't there only one way to put those 3 lengths together? Now, granted, your triangle might be rotated or flipped compared to somebody else's. But wouldn't you agree that all of you would have to have the same triangle? And once you put those together, wouldn't all 3 interior angles be exactly the same for everybody's triangle? So we've learned that if we know the 3 lengths of both triangles and we can prove that they're congruent, then the interior angles are also going to be congruent. So we don't have to prove the angles congruent at all, just the 3 sides. And so, if you decide that this is what you're going to use in a proof, at the very end of the proof, and I'll show you where this comes into play, you're just going to write SSS. Who would you like today? Who?
Jessica Roberts.
No.
You're not Jessica. Okay.
Are you looking for a student or for?
Student.
Oh yeah.
I
No.
did book with you yesterday. Yeah, you
All right. Sorry. Okay. So the next one that we're going to look at is SAS. What do you think that stands for? Side angle side. This is postulate 4-2, and it's commonly referred to as side angle side. Why is it, and if you look at the qualifications for this, it says two sides and the, underline this, included angle of one triangle must be congruent to two sides and the included angle of the other triangle. What does an included angle mean? The included angle means that you're given two sides. Remember on your homework in the workbook, you had a problem where you had to draw one side length that was 1 inch, and they called it VE. And the other side length was a 1/2 inch, and they called it HE. Didn't that mean that both of those segments had point E in common? All right, so if this was your 1 inch for BE,
Did you draw this?
yeah, and if this was your 1/2 inch for HE, didn't they tell you that E had to be a specific degree? So maybe this was your 1/2 inch, and that was HE, and they told you that this angle E had to be 60 degrees. Didn't everybody, if they did that correctly, didn't everybody have to have exactly the same looking triangle? You can't see? Move closer. Seriously, sit right there.
Wait a minute, did I say a 4? Like,
It's just like a light color.
page.
Move closer. Isn't there only one place for me to put the side of that triangle there? There's no other way to do it, right? Because I can't, this is like a hinge that can't be moved. It's stuck like this. I can't open it or close it and make it any bigger or smaller, can I? It's stuck like this. There's only one way to connect these two ends. Wouldn't you agree? This right here is the included angle. An included angle has to be in between two sides. In other words, it's the angle that's created by two sides. This angle over here, here's your two sides. This angle over here would not be an included angle. Is it in between those two sides? No. So if I gave you side-side angle, we will not be able to prove the triangle congruent. Because if that angle has to maintain the same, can't I open or close that to wherever I want to? And I'd have a different looking triangle. Alright, so write down at the bottom your definition, because you're going to forget, of what an included angle is. It's the very bottom. An included angle is the angle between two sides. And then in parentheses you can write the angle that two sides create. Alright, and so your shortened form for this, if you decide that you have been given or are able to prove a side angle side, that's going to be your reason SAS for proving those triangles congruent. Alright, so let's look at ASA. Angle, side angle, right? This is postulate 4-3. And you're right, it's angle, side, angle. And notice that this time we have two angles and the included side. So this time we don't have an included angle, we have an included side. So what do you think an included side is going to be? Yeah, the side in between two angles. I'll draw a picture of that in a minute. But right down at the bottom, the included side is the side between two angles. Or you can think of it as a side that has two angles bordering it, one on either side. So if I told you that you had to draw a specific length side, so let's say that that's your specific length side right here. Do you see that? And then I said, the angle here and the angle here, you have to make the following. You have to make this angle here 70 degrees and this angle here 20 degrees. This is for ASA. Isn't this an angle? There's the included side and then the angle. Isn't the side in between those two angles? What do you know about this angle up here? What's it going to have to be? 90. So there's no way, let's just say that I make the angle properly. I'm not using my protractor. But let's say that this is a 70-degree angle. I don't know where it's going to quit. And let's say that this is my 20-degree angle right here. Isn't there only one place that those two sides would intersect, right, to create that 90-degree angle? There's no other way that I could have drawn it if this is 70 and that's 20. There's no other way to draw that triangle other than that way. There's no other way. There's only one place that they're going to intersect and finish out that triangle. But look at AAS. Oh, don't forget to put up here what? If you decide that you have an included side, ASA is going to be your reasoning on your proof. What's the difference between ASA and AAS? Is the S in between the two A's this time? No. But this time, use a different color. This time, and I don't know what this postulate is, and by the way, this postulate is not in section 4.4. I'm not sure why they don't give it to you in section 4.4, but I'm giving it to you now. But it is angle, angle, side. But this time, and underline that not included, this time that side is not included. It's not in between those two. Which means that instead of telling you that you have to have 20 degrees there, I would tell you that you have a 90 degree and a 70. You have this side, you have to make a 70 here, and then that one has to be a 90. Isn't there only 1 degree that this angle could be there? Because they all add up to 180. So I couldn't make this go bigger or wider, because if I made it go bigger, wouldn't that be bigger than 90? If I made it go smaller, that'd be smaller than 90. Agreed? There's only one place again for that to lay. And it has to look like that. And so your reasoning for a non-included side would be AAS. What's the only, there's 2 sequences that you haven't seen up here. What are the 2 sequences you haven't seen? Ah. No, we've had SAA. It just is backwards. SAA is backwards from this. You can write these forwards or backwards. So SAA is the same as AAS. What else have we not had? We haven't had AAA, right? Angle, angle, angle. And here's the reasoning for that. Some child stole my rubber band yesterday. I had a rubber band to show to you. But imagine that you have a triangle whose sides are rubber bands. And it doesn't matter what the interior angles of that triangle are. Can't I stretch that triangle out, keeping the angles exactly the same, but have a bigger triangle versus a smaller? Think of your dilation that gets bigger or smaller? Look at this. If I had, I'm just going to use an equilateral triangle. If I had a small equilateral triangle, 60, 60, 60. Is there only one size of an equilateral triangle? No. I can have a bigger equilateral triangle, can't I? 60, 60, 60. So if all I gave you was the angles for 60, 60, 60, and they were congruent on both triangles, are those two triangles congruent? No. So just having the interior angles of a triangle does not make them congruent. Having the three sides does, but AAA will not prove a triangle congruent. Braden? Having what? AAS will prove them congruent. Right? So all the other ones will. All the ones on that paper will. The one that's not on there is SSA. We had one where we had SAS, where you had an included angle. Notice that with the side, we had an included side and a non-included side, but with the angle, we had only SAS. We had only an included angle. This, by the way, spells it bad words backwards, doesn't it?
What does it spell?
I don't know. It spells a bad word backwards, though, Grayson. We don't need to repeat it, though.
Oh, I thought
So if you're given two sides and an angle that is not included, no matter how you order them, it spells a bad words either forwards or backwards. So you need to write this somewhere on your sheet and cross it out and say,
You actually want us to correct that?
yeah, I want you to cross it out and say, if it spells a bad, capital letter bad word.
Well, but that it really isn't a bad word because it's like a name for a donkey. Like, you know.
It just depends on how you use it.
Wait.
Good point. It does not prove triangles congruent.
Why?
Just, okay, why? Here's why.
No, I have a question. Why on the SSA?
Shh. I'm going to show you why. So if I give you a side, so here's your side. There's a fixed length side right there. Right? And I gave you another fixed length side right here. There's a hinge that can be moved out or in, right? Because the angle that I'm going to give you is not there. The angle I'm going to give you is here. Let's say that this has to be 80 degrees here. Couldn't I continue this if that angle can be whatever I want it to? Can't this open or close? And this angle here can move so long as I keep this the same. If this opens or closes, these two angles together can change, whatever. I can open this, make it wider or close it, and I'll have different triangles.
I thought you said want us to write it like that.
I'm just proving to you that you cannot get a congruent triangle. I don't care if you write it that way, but I'm telling you that if you write SSA or ASS, forwards or backwards, it's a bad word, and it ought to hint to you that that's a big no-no, right?
No bad words.
No bad words. All right, yes.
Wait, so how do you find out if it's congruent?
You can only use the ones on this paper. If you're given information that doesn't match something on this paper, you can't, with that particular given information, prove the triangle is congruent. So you just can't. All right, so let's go ahead. I know we have a proof on the back of this, but before we do this, I'd like to do another problem really quickly first. No sleeping against the wall. All right, so take out your notebook. Take out your note spiral. Let's go. Shh. Braden, is that you back there talking?
No.
Okay, I didn't think so. My mistake. All right, so example 1.
What about the ones in the back of the sheet?
We're going to do that in a minute. All right, but I want to do this one first. So you're going to have some non-proof problems that you're going to have to do. This one says given triangle PQR with vertices P, which is 3, 4, Q, 2, 2, and R, 7, 2. And triangle STU with vertices S, which is 6, negative 3, T, 4, negative 2, and U, 4, negative 7. Show, notice it doesn't say prove, show that triangle PQR is congruent to triangle STU. You're going to have to find either SSS, SAS, ASA, or AAS to do that. You've only been given ordered pairs, so what would be the logical thing to do first? Well, we have to plot it first, and then from a graph, what's the easiest way to find something? You're not going to necessarily find angles off of your graph unless you use a protractor, and you're not allowed to use a protractor for these problems. So how are we going to find distance or length of a segment on a coordinate grid? You use the distance formula, right? So there's my coordinate grid, and start plotting your triangles. So that's what your triangles ought to look like. And you need to write yourself a note that you're going to use the distance formula. To compare sides. Are there any sides on here that I won't have to use the distance formula? Yeah, your horizontal and vertical lines, you won't have to use the distance formula. You can just count. So from Q to R, I've got 1, 2, 3, 4, 5. So that's 5. And this is a vertical distance. 1, 2, 3, 4, 5. Most likely, QR and TU are corresponding sides. They're the same. Most likely. So we only have to do the distance formula 4 times instead of 6. So I'm going to start with triangle PQR first.
Why did you write 5?
Didn't we count here to find the length? You don't have to use the distance formula for those. So I only have to do it twice. So I know that those sides are equal, right? And so I can automatically just say that QR is equal to 5. For this triangle. Then I'm going to find PQ. So I'm going to use the distance formula. I'm going to throw it into my template. Because you can't count for diagonal lines. It doesn't work. You can only count on horizontal and vertical. You cannot look at it.
Why?
Good thing, because Keegan brings up a point live. You're going to go, yeah, they're congruent. But you have to show it. You can't just say it. You can't cut them out and put one on top of the other and say, look, see, they're the same. We have to use our math. And you slope won't tell you side lengths or angle measurements. And you're not allowed to use a protractor. So we're stuck because I told you you can't. Because. All right, so we're going to throw in the numbers. You're going to take the difference between your y's and square them, the difference between your x's, square them, add them together, keep in the square root. Do I have to actually simplify the square root if I'm using it for comparative purposes? No. I can just leave it unsimplified. So for P and Q, here's your points P and Q. Aren't your y values 4 and 2? 4 minus 2. It really doesn't matter what order you put them in. And then your x values are 3 and 2. So you should end up with 2 squared plus 1 squared. What's 2 squared? 4. 1 squared. 1. 4 plus 1. Isn't that the square root of 5? You okay with how I got the square root of 5 from here? 4 plus 1 is 5. Alright, then the last one is PR for that triangle. So same template. My points for P and R, my y values again are 4 and 2. My x values are 7 and 3. Four minus 2 is 2 squared. 7 minus 3 is 4 squared. What's 2 squared? 4. 4 squared. What's 4 plus 16? So isn't that one the square root of 20? Alright, so there's one triangle done. I'm going to move it up so you can see my work for the other triangle. I'm going to work over here. But now you can't see my point, so you'll just have to focus on your own paper. Alright, so, again, don't we know that TU, and we're doing triangle STU. TU is 5. We just counted for that one. And then I'm going to start with TS. Again, here's my template. Your values for T and S. Your Y values are -3 and -2. Be careful when you subtract negatives. Don't you have to add the opposite? Right? Okay. Your X values are 6 and 4. So what's a -2 plus a +3? +1 squared plus 6 minus 4 is 2 squared. 1 squared is 1. 2 squared is 4. 1 plus 4. Doesn't that match with one of the ones from previously? So we have 2 matching pairs of corresponding sides. We have to do SSS. You have to have 3. So you do have to do the final one, SU. That's as far as it's going to go. And again, use your template. This time your values for S and U. Your Y values are -7 and -3. Be careful subtracting negatives. You have to do plus a plus. Your X values are 4 and 6. What's -3 plus a +7? +4. So it's not 4 squared. 6 minus 4 is 2 squared. What's 4 squared? 16. 2 squared. 4. 16 plus 4, square root of 20. So didn't we get our third matching set? Alright, so here's how you're going to write your answer. You have to write your answer this way. So, triangle PQR is congruent, and you have to make sure that you write a proper congruent statement. P corresponds to S, Q corresponds to T, and R corresponds to U. So triangle PQR is congruent to triangle STU. Didn't we use by SSS? If you had used SAS, you'd put that down. Okay? All right. Last thing we're going to do is the proof on the back of your paper. So look at the very back. Let's talk about the proof progression. It's really important to map out your proof first. Look at what's been given to you. Haven't you been given that MO is congruent to PO? So if I were you, I would put tick marks for MO and PO, right? Then you're told that NO, here's NO, bisects MP. What can you conclude when something bisects something else? That these two pieces here are equal. You're going to have to write that out a long way because you haven't been given the definition of a segment bisector yet. But we'll get to that in a minute. So that's all that was been given to us. Aren't these two sides, and isn't that a side? So far we have SS. I don't know if it's SAS. I don't know if it's SSS. But I definitely know it's not ASS, right? Okay. What else can we prove? We need one more thing. Right, we can prove that anytime two triangles share a side, can't we prove that that side is equal to itself? Through what property? Same thing equals the same thing. Reflexive property. So, since I have SSS, I've just mapped out my proof. I'm going to follow my proof by proving one side congruent, then another side, and then another side. Notice that my job is to prove the triangles are congruent. Once I've proven those three things, then I can say at the very end that that's congruent by SSS. So look at how the progression goes. What's this from?
Given.
Given. Okay? Notice what's in here. Don't we have one side right here? Isn't that our first S? Okay. Look at, how do we conclude from here to here? Wasn't that our bisecting? NO bisect MP. Didn't we conclude that those two pieces were equal? So here's how you're going to write it. If one line bisects another, that line is split into two equal pieces. Oops, pieces. Yeah, you can put that. All right, isn't that our second S? Would you agree? All right, then how did we get NO is congruent to NO? What property? You cannot just say reflexive, right? So we have to say reflexive property of what? Of congruent. What are those things? Segments. Aren't they segments? And then isn't that our third S? Haven't we completed all the three parts that we need? How can we now prove that those triangles are congruent? By SSS. Now, if I were you, stop for 1 minute. If I were you, I would go online and there are two more proofs. Stop. You've got to stop packing up and listen. There are two more proofs online. Here's one. And here's the second one. Both of them, the second one's slightly different than what we just did. The second one here is just like what we did but using SAS. I would stop for a minute. I would suggest that you go online and get those and look at them to help you with your homework. Now you can go.